So we're proceeding to work our way through different groups of organic compounds. So chapter 3 covers alcohols, phenols, and ethers. 21 crazy sections in this chapter. So what these compounds have in common is that they all have one oxygen atom, which is bonded to two other elements. So we need to remember what oxygen does. Oxygen is a group 6A element, meaning it has 6 valence electrons. So it's going to have 2 lone pairs, and it's going to have 2 bonding pairs. So the Lewis structure for oxygen is going to be something like this. 6 electrons. So this lone electron is going to form a bond, and this one's going to form a bond, and then we're going to end up with these 2 lone pairs. It can form 2 single bonds, or it could form 1 double bond, but the ones we're talking about in this chapter are the 2 single bonds. Carbon always forms 4 bonds in organic compounds. Hydrogen forms 1, and the oxygen forms 2. So there's just a different drawing. So carbon and hydrogen are not going to have any lone pairs on them. They're just going to bond. Oxygen will form 2 bonds, like I said, 1 double or 2 singles, and you are going to have lone pairs on there. And that affects its geometry too. Okay, so what is an alcohol? An alcohol is an organic compound in which we have a hydroxyl group attached to a saturated carbon atom. So the hydroxyl group is the OH, and that is the functional group for alcohols. Alkanes didn't have any functional groups. Alkenes, the functional group was a double bond. Alkynes had a triple bond functional group. And so the alcohol's functional group is this hydroxyl group. So the general structure is R, where R could be any alkyl type group with an OH on it. So examples are CH3OH, C3H7OH, etc. It's important to note that the OH in alcohols is not ionic. This is not hydroxide ion. It's a hydroxyl group. Hydroxide ion is OH minus that has a negative charge and is an ion. The hydroxyl group is covalently bonded to something and doesn't have an overall charge. If we look at water and methyl alcohol, which is the smallest alcohol, we see that they have some similarities. Here's water. Because of the 2 lone pairs here, water has this bent shape. And the angle here is about 105. Methyl alcohol, here we have this OH group, and here we have a methyl group. And so this basically is subbing in for the hydrogen on the water. So we can think of alcohols as being alkyl derivatives of water, or we can think of them as being hydroxyl derivatives of alkanes. So it's depending on which part you look at as the main part. But alcohols are going to be, they have some similarities with water.